All right, so this is proof worksheet number 5, and I'm going to walk you through a couple of these proofs, and then the remainder of the class period you'll have to complete the worksheet on your own. Okay, so I see this here, and I'm kind of scatterbrained, so this immediately, it's a lot going on with these triangles overlapping. So sometimes when triangles are overlapping, it's actually easier to draw them out separately. So that's what I'm going to do right now. So this is triangle D and G, and this is triangle I and O. And obviously these are not to scale. Okay, so if I look here, first thing I'm given is angle NIO is congruent to angle NGD. So if I go ahead and highlight those, so angle NIO, so this angle here, is congruent to angle NGD, which is this angle here. Okay, I'm also given that NO is congruent to ND. Okay, so side NO is congruent to side ND. Okay, and then next, I see angle N is congruent to angle N. So angle N is right here, and you can see that this is a part of both of these triangles. Okay, so angle N is right here in this triangle and right here in this triangle. And so remember, anything is congruent to itself, that's the reflexive property. Okay, now I want you to notice that what we're trying to prove is a little different than what we've been proven so far. Okay, we've been proven that triangles are congruent. Okay, and we're still going to prove triangles are congruent. Notice that's what we're going to do here. Okay, but we're going to use what's called CPCTC. Okay, and that stands for corresponding part of congruent triangles are congruent. Okay, so if you say that a couple times, it'll stick. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles. Okay, so what that means is that after we prove that two triangles are congruent, then we know all the pieces have to be congruent, including pieces that aren't mentioned in the proof here. Okay, so with that said, this we use only after proving congruent triangles. All right, so if I keep going with my proof, okay, the next step, it says triangle INO, which is this triangle here, okay, is congruent to triangle GND, which is this triangle here. And they are, as you can tell by what I've marked, this is by angle, side. So up to this step, this is nothing new. Okay, now here's what comes new. This part right here. Notice this is after we prove triangles are congruent. Okay, so because we have stated that this triangle and this triangle are congruent, that means every piece of the triangle of one has to be congruent to that piece of the triangle of the other. So notice here where I say angle D is congruent to angle O. If I look here, angle O is in the last position, angle D is in the last position. Therefore, I know because they are congruent, angle D and O have to be congruent. Okay, so this is when I use the CPCTC. Corresponding parts of congruent triangles are congruent. All right, let's skip down to number 8 on the worksheet. Okay, here's number 8. Okay, and hopefully what's immediately drawn to your attention is that we have a pair of vertical angles. Okay, so we will most definitely use that. All right, so AE bisects BD, and AB is parallel to DE. All right, so let's start with AE bisects BD. So AE is this, bisects BD. So this here is what's being bisected. So if that's being bisected, that means that BC has to be congruent to CD. So BC has to be congruent to CD. Okay, and remember, that is just by the definition of bisect. All right, so next, let's move on to AB is parallel to DE. Okay, that's the other given. Now, we should know by now that parallel does not mean congruent. These lines are parallel. They are not congruent. Okay, so remember when I have parallel lines, I'm either thinking alternate interior angles or corresponding angles. And we actually have two pairs of alternate interior angles here. And I'm actually going to use those just because this will be a little quicker. I'm not even going to use vertical angles this time. If you want to use vertical angles, you are more than welcome to do that. But it's going to be actually easier since we have to use two steps for vertical angles. It's actually going to be easier just to use two pairs of alternate interiors. Okay, so using alternate interior angles, we know that angle A is congruent to angle E. So I'm going to write that. Angle A is congruent to angle E by the alternate interior angle theorem. Okay, and likewise, I also know that this angle here, angle B, is congruent to angle D because those are also alternate interior angles. Okay, now that I look, I have angle, angle, side. Angle, angle, side. So I can go ahead and prove that triangle ABC is congruent to triangle EDC by the angle, angle, side congruence theorem. Okay, now I could have used vertical angles, and then depending on which one of these angles, it could be angle, angle, side, or you could have done angle, side, angle. But like I said, I just chose to do two alternate interiors because it was just shorter proof. But other than that, vertical angles would have been perfectly fine too. All right, last one we're going to look at is number 12. Okay, so I'm given that AB is parallel to DC, and then I'm also given that AB is congruent to DC. Okay, those two are what's given. All right. So if I look, I want to prove that angle side AE is congruent to side DE. Okay, so that makes me think I probably want to prove these two triangles are congruent. So that's what I'm going to do, because then I could use the corresponding parts of these to show that this and this side are also congruent. Okay, so because these are parallel, remember that means I need to look for alternate interior angles. Okay, so alternate interior angles would be this angle here. Ooh. Oh my goodness, it's moving on me. Alternate interior angles would be this angle here. Okay, come on, pen. There we go. Now it's working. Okay. So I could write alternate interior angle theorem goes right here. Okay, now on number 4, I'm shown the angle ABE, so this angle here is congruent to DCE, which is this angle here. Okay, so notice those are also alternate interior angles, so we could do alternate interior angle theorem again. Okay, well now if I look at this triangle up top and this triangle down below, okay, I have a side angle, angle side angle and an angle side angle. So I could say those triangles are congruent by angle side angle. So triangle, if I just write ABE, so triangle ABE is congruent to triangle. Now be careful, remember the order of the second has to match the order of the first. Okay, so if my first angle is A and my angle A is green, my green angle has to be first over here. So it'd be triangle D. Okay, B is second, and that was my purple angle. So C would be my second, and then E. And remember that was by angle side angle. Okay, now that I know that these two triangles are congruent, okay, once again, that would be this triangle here and this triangle here. These are congruent, which means that every single part of each of these is congruent to the corresponding part of the other. Okay, so if I look AE, which is first and last, okay, that has to be congruent to first and last, which is DE, which is exactly what this is saying. So I can go ahead and go a step further and say AE is congruent to DE. And once again, that is by the corresponding parts of congruent triangles are congruent, okay? Meaning that I know those triangles are congruent, which means every corresponding part of one is congruent to the corresponding part of the other.